Okay, so I want to show you how to use Python to solve systems of linear equations. So here I have a Jupyter notebook that's running Python 3, and the system of equations that I want to solve is this one we saw last time in class. X plus y plus 2 is equals 9, 2x plus 4y minus 3 is equals 1, and we have a third equation here. And we want to solve for x, y, and z. We saw that what we want to do is focus on taking out the coefficients and turning these equations into a matrix. This time I've taken the 9 coefficients on the left-hand side of the equal sign and put them into a matrix here. So again, the first row has coefficients 1x, 1y, 2z, and that corresponds to the first row of the matrix. Similarly, the second equation, 2x, 4y minus 3z, 2, 4, and minus 3 appear in the second row, and so on. And then here on the right-hand side, 9, 1, 0. Previously in the augmented matrix, we put them over here, but this time what I want to do is separate them out into a separate column vector and call it B. So this is just written in Markdown or LaTeX. That's not part of Python programming. And so here is where the Python programming part begins. So the first thing we want to do is import numpy, and just so that we don't have to keep writing numpy every time we want to refer to a function or program in numpy, we write as np, or as anything you want, just as to indicate that np refers to numpy. All right. So NumPy stands for Numerical Python. It's a library or module containing programs people have written that solve, for example, systems of linear equations and a whole bunch of other things. Okay, so first we want to create this matrix A in Python. And here's the notation to do that. So we set A equals NP, so that refers to the NumPy library or module. And then it has an array. So these matrices in Python are called arrays, and the notation is using lists. So here's a square bracket. Well, first of all, there's these round brackets, and then within that, there's a square brackets, and within those outer square brackets, there's the rows of our matrix, and each row itself is encompassed or surrounded by a square bracket. So the first row, 1, 1, 2, that's square brackets 1, 1, 2, followed by a comma, and then 2, 4, minus 3, square brackets 2, 4, minus 3 is the second row, and 3, 6, minus 5 square brackets is the third row. Okay, so then we get a matrix A. In Python it's called an array, but okay. And then here I just typed in A, and then hit the run command or shift return, and that gave me this output. And so we see that this matrix A, or array, is indeed how I want it to look like. Okay, and then similarly, I construct this matrix B, and it has just plain 9 in its first row. So I need square brackets 9. And that's again within some other square brackets. And then similarly square brackets 1, square brackets 0. And comma separating the two. Okay. And then finally here is the code in line 8 or input 8 for how to solve the equation A, where A is the coefficients, the matrix of coefficients, and B is this matrix out here. And that's np.linalg.solve A, comma B. And then that output I'm going to capture with the variable x. I could call it whatever, but it's typical to call it capital X, or yeah, that's what I did here. And then I asked Python, well, what did you find for x? And then I type in capital X, hit Shift Enter, and it gives me that X is this 3 rows, 1 column matrix consisting of 1, 2, and 3. and that indeed is the solution to the answer to solving for x, y, and z. Well, x is 1, y is 2, z is 3. It just happens to be for this particular system of equations. We indeed check that the first equation here satisfies 1 plus 2, that's 3, and then 2 times 3 is 6, so that's a 9. Okay, and then to check whether indeed this x that we found, 1, 2, 3, is a solution, we can matrix multiply. And that's something we haven't learned yet, but we'll learn in the next section of how to multiply two matrices. And the code for that is np.matmo. So that stands for matrix multiplication, A times X, and we indeed get B. One other thing I'll just add here is how to find the shape or the dimensions of each of these matrices. That's what you want to do, is type in the matrix and then type in shape, and then hit either the run up there or hit shift enter. So A is indeed a 3 by 3 matrix, and that's what it enters: 3 rows, 3 columns. The number of rows is always first, the number of columns is second. Let's try B dot shape. Shift enter. B is a 3 by 1, 3 rows. That's what we had here: 3 rows, 1 column. So that's why B is a 3 by 1. And then finally X dot shape. Shift enter, and that's also a 3 by 1 matrix.